Hi students, in this video we're going to look at applications of arithmetic sequences, first of all looking at simple interest. Alright, so after watching this video you should be able to use arithmetic sequences to analyse and model practical situations, and in this video in particular looking at simple interest. Alright, big things to remember. So the definition of our arithmetic sequences, that is a sequence where we're going up in the same value or down by the same value each time, such as this one, where we're just going up by threes. We also want to recall the recursive and general form of our arithmetic sequences. So remember, we've got something like t1 equals some number, and then our next term, tn plus 1, is the term we're looking at plus whatever our common difference is. That's our recursive form, and our general form, tn equals t1 plus n minus 1d. So remembering those two from previous lessons. All right, so simple interest. It occurs when the amount of interest on a loan or investment is calculated as a percentage. Okay, as a percentage of the initial investment or loan. And so the idea is, with simple interest, the amount of interest that you earn for an investment or that you have to pay back for a loan, it stays the same every year, year on year. Simple interest. So considering a loan of $2,000 at simple interest at 10% per annum, paid off after 3 years. So what we're going to do is consider V naught. Now let's talk about these variables. We might say V can be our value, and our subscript can tell us after how long. So value after V0 or V naught will be our value after 0 years. So our value after 0 years, well, that will just be how much we borrowed. So in this case, V naught will be $2,000. Now, what we want to know is how much interest are we going to have to pay every year? So our interest is, we're told it's 10% per year. So 10% of $2,000 is actually just $200. And so each year we are going to be charged $200. So if V naught is 2,000, after 1 year, we would have to pay back $2,200. After 2 years, we'll have to pay back $2,400. After 3 years, after 3 years, we'll have to pay back $2,600. Now, key thing to notice here, guys, is that in each case we are going up by $200 each time. Okay, we're going up by $200 each time. That looks like an arithmetic sequence. Okay, so how we can write this is, if we're using our recursive formula, we can say V naught is equal to A, and that's just whatever our initial loan or investment was. And then the value at any time is going to be equal to the value that we had the year before or the time before, plus whatever our common difference is. And this common difference D is just the interest that we keep adding on as we go. If we're writing it in our general form, and this is where it gets a bit interesting because we are using V naught, not V1. Okay, so bear that in mind. As we would have done with our previous arithmetic sequences, Vn equals V naught plus Nd, where N, again in this case, is number of years after investment or loan. Okay. All right, now let's do an example. We've got $500. Sorry, $500 invested in a simple interest account for 5 years at 5%. Nice and simple. 555. Set up a recurrence relation for this statement. That's pretty easy. So V0 is $500. We were told that we had $500 invested at the very start. Now, our common difference is going to be the amount of interest we have to pay, which is 5% of $500. Now, just using our calculators, we can say that's $500 times 5 over 100, which equals $25. So putting that all together, we can say V0, our initial investment was $500, and for Vn plus 1, after any year, our value will be what it was the year before, plus the $25 of interest. Okay, so we're getting $25 of interest every year, and we're just adding that on each year to get the next year. All right, so using the recurrence relation from part A, complete the following table. All right, so we know that our initial investment was $500, and we just worked out that our interest was $25. So then after this year is finished, we'll have $525 invested. So then for the next line, again, we'll be starting with $525, have $25 of interest, and that will reach $550. So following that same sort of pattern, we can fill out the rest of this table. I'm just going to do it quickly by saying the interest is $25 all the way down. And so that'll be $550. This will be $575. This will be $575. This will be $600. This will be $600. And this will be $625. And there's our table completed. So at the end of 4 years, okay, at the end of 4 years, the investment will be worth $625. All right, now what we want to do is sketch ourselves a graph of this data. So let's go do that for the 5 years. So this can be our N. Let's use a different bit of color for our labeling down here. So we've got N down the bottom here, that's our number of years. And then Vn, our value at the very top here. And so we'll start here at 0. And maybe up here we'll go to 1, then 2, 1, 2, 3, 4. That'll be a good place to start. And we'll start here at, I don't know, $500. And then 525. $550. It's up there. $575. 600. 625. And then we can just plot our points. So after 0 years, we had $500. After 1 year was $125. 2 years was $550. 3 years was $575. Which is up here. Also, 4 is 600 up here. There's our graph, and if we want to, we can then draw ourselves a line, which we'll do for this next part. So we're going to use the graph to determine the value of the investment after 7 years. So we've got to say then we've got to go up to 5, then 6, then 7. So it'll be somewhere up here. What we can do is just use a line to go through these points, obviously in a way that's much neater than what I've done it. And then when you've done it neatly and you read off the graph, you'll get an answer of $675. And that's how we can calculate simple interest. Alright, so after watching this video, guys, you should be able to use arithmetic sequences to model and analyze practical situations, including simple interest.